The Office of Naval Research. Revolutionary research. Relevant results.
I'm Dr. Timothy Bentley, and I'm with ONR, that's the Office of Naval Research, Code 34, which is the Warfighter Protection Department. Our department's interested in improving combat casualty care, so we develop devices, treatments, and drugs for taking care of people injured on the battlefield. Part of the organization that I'm responsible for, it's called the Force Health Protection Future Naval Capabilities Program, a group of projects that last 5 to 8 years in total before they get to the field. Navy captain Dr. Peter Rhee was deployed to Afghanistan in about 2003. He found that the equipment that he had at that time wasn't really up to the task. It was a little bit older, it wasn't small enough, it wasn't portable enough to really meet all the needs that he had.
One of the projects that I was able to get initiated through the United States Navy and the Office of Naval Research was a product called a wireless vital signs monitor. The thinking was, why can't we put a monitor-like device directly onto the patient, and it gives us all of this information, and it just gives us a heart rate, blood pressure, and what we call a pulse oximeter. And that's the information that doctor uses for all of the things that we need to know so we can say whether the person is going into shock or not.
The fact that it's primarily wireless, that means that you don't have a great large number of wires, connections going between the patient and the monitor. It makes it much easier to transport the patient without snagging these cords on something. It's particularly important in a field environment where there's equipment all over the place and it's quite rough and kind of confused and sometimes very almost frantic. There's so many things going on. The wireless vital signs monitor ends up being all the monitoring capabilities that you might have in a hospital, but built into a very small unit. Something, the size of 3 or 4 packs of cards in that neighborhood. The ECG, the non-invasive blood pressure, the pulse oximeter, all gets presented on a video screen. So not only do you get sort of digital numbers, your heart rate, 60 or 70 beats a minute, you actually see the traces, so it's much easier to, the traces in this case would be a plot or a graph of the information, and that lets you watch the trends that the patient is going through. It's important not only to know how he's doing right at that moment, but to know if he's getting better or worse. We've recently seen a wonderful use of the WVSM in the civilian world. Dr. Peter Rhee, who came back from Afghanistan looking for a more modern device, has recently used one in the transport of Representative Gabby Giffords.
One of the prototypes was sent to me. It is now, since it is FDA approved, we were able to transport her from Tucson, Arizona to Houston with this device in place, so that the physicians and the nurses that were accompanying her were able to easily monitor her without having her attached to a lot of wires.
It was a perfect example because there was a patient who needed to be moved out of the hospital to a helicopter, flown to another city, and then moved back into another hospital. So again, it will find plenty of usage, I believe, in ambulances, in air transport, and even within civilian hospitals for patient movement.
Office of Naval Research was able to fund it, to develop it, test it, get it to the model that we wanted to. Now that it is taken off by itself with its own company and is FDA approved, we're going to try to see if we can find a way to get this to the warfighters in the field.
Each iteration makes it smaller, tougher, more capable, longer lasting. I think the WVSM is a perfect example of the sort of things we do in force health protection. As I mentioned, we develop drugs sometimes, pharmaceuticals, we develop procedures, rules, for instance, of how long and how far you can exercise in very hot, humid conditions, how deep and how long you can dive underwater, for instance. But in the development of medical devices, this is a perfect example. The need has been identified by the field. Office of Naval Research has responded to this need, used its resources in research and development to create a device that now will go back to the field.